Alright, so let's talk about taking some really basic derivatives or differentiating some really simple functions using derivative rules. If you're not familiar with the derivative rules or the concept of the derivative or anything like that, go ahead and check out some of my previous videos on this playlist. They'll show up above this video on this playlist, the derivatives playlist for my Calc 1 video series. So those should be able to clear everything up for you if there's any trouble, and if not, let's go ahead and dive straight into this. So I'll talk about the rules necessary for each problem and write them down each time as we continue along here. But let's go ahead and evaluate something that, if you've seen this set of videos, we've already evaluated. Let's evaluate the derivative of f of x equals x squared. This is really simple. This is one of the most frequent or the most common derivatives you will see throughout calculus, because it's a very, very simple derivative to take the very simple function to differentiate or take the derivative of. So let's talk about this really quickly. What rule do we need to use? Well, the only rule we need here is the power rule. That's all we need. And the power rule states that x to the nth power prime is just equal to n times x to the n minus 1 power. So this is all we need here. So we know that our n is equal to 2, and that 2 minus 1 is just equal to 1. So our work is really not that difficult here. We're just going to bring down this 2 in front because we put the n and multiply it by the variable. So we're going to have 2 times x, and we're going to raise x to the n minus 1, or we're going to raise it to the first power. Well, raising it to the first power doesn't change anything, so we can just forget about this 1, don't even worry about it. And we can forget about this multiplication sign too, because we don't even need it. So the derivative of x squared we can determine is just 2x. Very simple, right? So this is an extremely easy derivative, one that doesn't take a lot of work or time. So let's go ahead and talk about doing some more that are slightly more labor intensive. So I'm going to take the derivative of a really simple polynomial function here. F of x is equal to x squared plus 5x plus 7,392.4. Now, if you're familiar with the rules and can kind of see ahead what we're about to do, this derivative shouldn't look at all scary. Well, we know the derivative of x squared, and let's just talk about the power rule again really quickly, just in case. We can figure out the derivative of x squared because it's x to the nth power. X to the n prime is just n times x to the n minus 1, so we can determine from that that x squared is going to derive down into just 2x. Alright, very simple, not very hard to deal with. Now we're going to have 2x plus this next derivative here. Derivative of 5x. What's that? How are we going to figure that out? Well, let's talk about another rule here. Alright, this is the constant times a function rule. We're going to need two rules for this. We're going to need the rule that tells us what x prime is equal to, and we're going to need the rule that tells us what constant times a function prime is equal to. So, within parentheses, a constant times a function, both of those things multiplied together, if we're taking the prime of that, well, it's just the constant times the function prime. So we're basically just removing the parentheses is all we're doing. So the constant we no longer worry about its derivative, it just stays itself, and then we just take the derivative of the function. So that's the first rule we're going to need to know in order to take the derivative of 5x here. But then the second rule we're going to need to know, well, we know the constant, so we know that this is just going to be 5 times something. So we can go ahead and actually rewrite that. We just have 5. We know it's going to be 5 times something, some value. We don't know what, so we'll say 5 times something plus something else. Now, all right, let's keep talking. X prime, another rule that we have, is that x prime is always equal to just 1. So if x prime is always equal to 1, then this is 5 multiplied times, well, 1. So it's just 5. All right, now we're adding something else. Now we need to know only one other rule to figure out this last bit here, and that is the constant rule that says any constant prime is just 0. And my video on derivative rules explains the graphical reason for that. So, all right. Any constant prime is 0. Well, 7,392.4, though it is a large number, sort of a large number, at least relatively, it's just going to be 0. So we have 2x plus 5 times 1 plus 0. Well, what is this all just going to end up equaling? Well, this is just 2x plus 5. We're done. That's how simple that derivative is. So, power rule, constant times a function rule, x prime rule, and c prime rule, constant rule. So that's all we had to know for that. So let's try one that's a little trickier. F prime of, let's see, well, let's just write f of x again like we did last time. My bad, I'm sorry about that. All right, if we can draw an f here, f of x is equal to x to the 7th plus 6x squared plus 5x plus 23 plus, or minus, let's make it minus 4. Okay, so here is our function, and I think x to the 7th looks a little terrible here, so let me fix that for us. We have x to the 7th, okay? So what we're doing now is we're going to say, well, we just need to use the power rule is all we really need to use. So power rule is all we need to do on the first one here. Well, we have x to the 7th. Well, we said that the power rule said that x to the nth power, when we take its prime, well, that's just n times x. Let's make that actually look like a little multiplication symbol. N times x to the n minus 1. Well, what is our n here? Well, our n for this just equals 7. So we know that 7 minus 1 is just 6. So we can bring down our 7. Let's change colors here to make it obvious what we're doing. We're just going to bring down a 7, and this is going to turn into 7x to the n minus 1, or just 6. So 7x to the 6th, plus something else. So draw some little red arrows here. All right, now let's tackle this next piece. What rule do we need to know for 6x squared? Well, it looks exactly the same thing, really. It's just another power, so let's use the same power rule. Our n here is 2. So for this piece, our n equals 2. So 2 minus 1 is just 1. But now there's a little tricky bit involved in this. When we bring down this 2 here, signify with this red marker, when we bring down this 2, we have to multiply it by the coefficient in front of 6. So it's going to end up being 12x to the first power. So, all right. Now, next, we have 5x. Well, remember, that's just the constant times a function prime. That rule is really pretty simple. C times f prime is just equal to c times f, the prime only on the f. So not much work for us to do there. We know that it's just going to be 5. 5 times 1, all right, because x prime is just 1. And lastly, we need to recognize 23 and negative 4 as coefficients, and we know that c prime is always equal to 0. So these, let me rewrite this in green ink, my bad. This was plus 5, and then this is going to add 0 and subtract 0. So we don't need to worry about these pieces, they don't matter. What this is really going to end up being is just 7x to the 6th plus 12x plus 5, and this is our derivative. So in another video we'll talk about the product and quotient rules, which can be a tad more tricky, but for now we've talked about the product, or not the product, the power rule, constant times a function, and the rule for x prime. So that's enough for this video. 3 pretty simple derivatives to take using rules. It is definitely much less labor intensive than having to worry about doing the limit definition of the derivative and all of the nonsense that goes into that. So we're done here.